Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 4 to the power of x plus 10 to the power of x is equal to 25 to the power of x. Now what I'm first going to do is I'm going to divide both sides by, 4 to the power of x. So then first off, these two cancel out. So I have 1 plus 10 to the power of x over 4 to the power of x is equal to 25 to the power of x over 4 to the power of x. Now, if I have something in the form a to the power of m over b to the power of m, this is the same thing as a over b to the power of m. So for both 10 to the power of x over 4 to the power of x and 25 to the power of x over 4 to the power of x, I can rewrite this as 10 over 4 to the power of x and 25 over 4 to the power of x. Now 10 over 4, this can be simplified to 5 over 2. And 25 over 4, this can be simplified to 25, this is 5 squared, and 4, this is 2 squared. So I have 5 squared over 2 squared to the power of x. Now remember how I said if I have something in the form a to the power of n over over b to the power of m, this is equal to a over b to the power of m. So in this case, I have 5 squared over 2 squared, so we can rewrite that as 5 over 2 squared, and then we have to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And for multiplication, the order doesn't matter, right? Meaning, a to the power of m to the power of n, this is also equal to a to the power of n to the power of m. So 5 over 2 to the power of 2 to the power of x, we can rewrite that as 5 over 2 to the power of x to the power of 2. So we simply switch the order of 2 and x. So now what I'm going to do is I'm going to let u, the variable u, equal 5 over 2 to the power of x. So now if I substitute in u for 5 over 2 to the power of x, I get 1 plus u is equal to u squared. Now I can subtract u and 1 on both sides, so then these two cancel out, and I would have u squared minus u minus 1 is equal to 0. Now I need to plug this in to the quadratic formula, which is, if you didn't already know, negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, the coefficient in front of u squared is 1, this is negative 1, and this is negative 1. So a is equal to 1, b is equal to negative 1, and c is equal to negative 1. So now if I plug this in, I get negative 1 plus or minus the square root of b squared is negative 1 squared minus 4 times a, which is 1, times c, which is negative 1. And I'm dividing this by 2 times a, which is 1. Now if we simplify this, Negative 1 is positive 1, plus or minus the square root of negative 1 squared is 1, minus 4 times 1 is 4, 4 times negative 1 is negative 4, all over 2 times 1 is 2. Now this is equal to 1 plus or minus the square root of 1 plus 4, which is 5 over 2. So this gives me two solutions. I have u is equal to 1 plus the square root of 5 over 2, and I have u is equal to 1 minus the square root of 5 over 2. So remember how we stated that u is equal to 5 over 2 to the power of x. So if u is equal to 5 over 2 to the power of x, and I already have two values of u. So let's first try 1 plus square root of 5 over 2 and see what we get. So I'm going to substitute in 5 over 2 to the power of x for u. So now I get 5 over 2 to the power of x is equal to 1 plus the square root of 5 over 2. Now I can take the log on both sides, so I have log 5 over 2 to the power of x is equal to log 1 plus the square root of 5 over 2. So now if I have something in the form log a to the power of b, this is equal to, I can actually move this exponent b to the front. So I'll have b times log a. So log 5 over 2 to the power of x, I can move this exponent to the front. So this will get me to x times log 5 over 2. This is equal to log 1 plus the square root of 5 over 2. So now if I divide log 5 over 2 on both sides, these two cancel out, and I will be left with x is equal to log 1 plus the square root of 5 over 2 over log 5 over 2. Now if I have something in the form log a over b, this is equal to log a minus log b. So log 5 over 2, this is equal to log 5 minus log 2. So now I have log 1 plus the square root of 5 over 2 over log 5 minus log 2. And this is equal to approximately, if you plug this into a calculator, x is equal to 0.525. Now for our other value of u, we have u is equal to 1 minus the square root of 5 over 2. And now if I plug this in, I get u 1 minus the square root of 5 over 2 is equal to 5 over 2 to the power of x. However, this actually is rejected because 1 minus square root of 5, that is a negative number. And you can't take a power of a positive number and make it negative. So this has no solution, meaning our only solution for x is 0.525. Hey guys, welcome back to Clear Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So we have 2 to the power of 10 minus 2 to the power of 9. Now what I'm first going to do is I'm going to rewrite this 10 as 9 plus 1. So we have 2 to the power of 10 minus 2 to the power of 9. and this is equal to 2 to the power of 9 plus 1 minus 2 to the power of 9. Now, an important property of exponents is that if we have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So the base simply distributes with the exponents. So I'm going to use this property for 2 to the power of 9 plus 1. We can think of 2 as a, 9 as m, and 1 as n. So this would equal to 2 to the power of m, which is 9, times 2 to the power of n, which is 1. And now we are subtracting this with 2 to the power of 9. And now this is equal to, now I'm going to factor out 2 to the power of 9 from this. So if I factor out 2 to the power of 9, I get 2 to the power of 9 times, now 2 to the power of 9 divided by 2 to the power of 9 is 1. And then I have, 2 to the power of 9 times 2 to the power of 1 divided by 2 to the power of 9 is simply just 2 to the power of 1 minus 2 to the power of 9 divided by 2 to the power of 9 is 1. And now this is equal to 2 to the power of 1 minus 1 is simply 1. So I have 2 to the power of 9 times 1, which is equal to, anything times 1 is itself, so 2 to the power of 9. Now, for 2 to the power of 9, this is equal to 2 to the power of 4 times 2 to the power of 5, because, remember, a to the power of m plus n, a to the power of m plus n is equal to a to the power of m times a to the power of n. So now, 2 to the power of 4 is 16. 2 to the power of 5 is 32. So we have 16 times 32. We have 32 times 16. 2 times 6 is 12. We carry the 1. 6 times 3 is 18. 18 plus 1 is 19. Then we add our 0. 1 times 2 is 2. 3 times 1 is 3. 2 plus 0 is 2. 9 plus 2 is 11. We carry the 1. 3 plus 1 is 5. So our final answer is 512.